now we are going to attempt an example of finding the distance from a point with coordinates 1, -2, 4 to the plane with its given equation as 3x plus 2y plus 6z equals to 5. Now imagine this is the plane and this is the point. Now you're supposed to find the vertical distance h. So very simple. We take any point, alright, on the plane. So let's say we take a point. And this point we call it R. Or maybe we call this P. Okay. Now, what is the equation of this plane? The equation of this plane is given as R dot 3, 2, 6 and is equals to 5. Now this is the vertical distance that we want to find. Now, so to find this distance, all right, this is actually the length of projection of px onto the unit vector n. Okay, so the required distance, maybe I use a different color. So the required distance h will be equals to mod of xp dot unit vector n. Alright, you need to take the modulus because distance is always positive. Now this might comes out to be negative, depends on the angle between the vector with the normal. So what is xp? Alright, now how to find the coordinates of p? You can take any point on the plane. Now to find p, so let p be any point on the plane. So if you expand this equation will be of this form. Maybe I write it over here. This will be 3x plus 2y plus 6z equals to 5. Now let's say we let x equals to 0 and z equals to 0. Alright, then you will find that y is equals to 2.5. Alright, you can put any values of, you can let two of the unknown be any number. Then based on that, the third one must satisfy this equation. Then that point will be on the plane. So I think it's very easy to put x is 0 and z is 0 in this case. Then y will be equals to 2.5. Okay, right now how to find xp? Now xp will be given as OP minus OX dot unit vector n. Alright. Now what is OP minus OX? Now let this is x, okay? This point we call it x. Now, so OP minus OX. Now this is P, alright? So this minus this. So what will you get? Alright? So 0 minus 1, you get minus 1. Alright? Then y is 2.5. 2.5 minus 2, you got 4.5. You got 9 over 2. Alright? Then you have 0 minus 4, you have minus 4 over here. Dot the unit vector n. Now this is the vector n. So you have to divide this by the magnitude. So this will be equal to 3, 2, and 6. Now to make it a unit vector, you have to divide by its magnitude. And what is its magnitude? So you do 3 squared is 9. Alright, so 9 plus 4 plus 36. So this is 49. So that will be equals to 1 over 7. Okay. Then what, when you do this dot product, what is the answer? This is minus 3 plus 9 minus 24. You're supposed to take the modulus of this. Alright. Then that will give you 18 over 7. So that is the answer. Okay. We are now going to look into another method of finding the distance of a point A to the plane given its equation r dot n equals to d. Now there's three scenarios as to the position of the point A relative to the origin and the plane. Case 1, you find that the plane, all right, which is represented by the green line, all right, is in between the origin and the point A. Now for case number 2, the point A is in between the plane and the origin. For case 3, the origin is in between the plane and the point A. Now let's consider a positive D. Now, your given equation is of the plane is r dot n equals to d. Now, so r dot unit vector n is equals to d1. All right. So what does d1 represent? d1 represent the distance of the origin to the plane, the perpendicular distance. Now, why? Now let's imagine this is the plane and this is the origin. Now r represent any point on the plane. All right. So r is a position of any point on the plane. So this is r. And this is your vector n. Let's say this is your vector n. No, it shouldn't be unit vector. Now, so what is this distance here? This distance will be given by, is the length of projection of r onto n. So we learn in dot product, all right? So d1 will be equals to mod of r dot unit vector n. Okay. Now, this is actually r mod of n cos theta. Okay. Now this is the mod of unit vector is 1. So you are left with mod of r cos theta. Alright, so when your equation of plane is given by r dot unit vector, alright, if d is positive, then the d represents the distance of the origin to the plane. So what does this represent? This is the distance of origin to the plane. So you will have d1. All right, in this case we use d1. All right, this distance is d1. Now what is this distance h? H is represented by OA dot unit vector n. All right. This is the distance h. Now, so what is the distance of point A to the plane? It will be given by h minus d1. Right? So this is the distance. Now, what is h minus d1? H minus d1 is mod of OA dot unit vector n minus d1. Now, we are working with a positive n and this is A. You realize that in this scenario, OA dot n is positive, all right? So whether we put the mod or we don't put the mod, it is the same. So for now, maybe I will just leave it as without the mod. Minus d1. Okay, let's call this d. Big D, okay? Now let's look at scenario 2. I use a different color. Now, what is this distance h? Now h is given by the modulus of OA dot unit vector n. Alright. Now this is also positive, alright, because theta is a cube. Alright, theta is a cube. So this is given by, this is the same as OA dot n. Alright, because theta is a cube, alright, in this scenario. Alright. Now, so what is the distance? Alright, so the required distance will be d1 minus h. Alright, d1 minus h. Now what is h? H is d1 minus OA dot unit vector n, and that will give you d1 minus d. Okay. Now, in this, just in case, all right, now your OA dot n, all right, I will use, maybe I use a blue one. OA dot n is equals to d, all right, for both of these scenario. Okay. Now, let's look at D, case 3, I mean. Now, what is this distance h? H will also be, is the same, is equals to OA dot unit vector n. I should put the vector sign over here. Now, what this is OA dot unit vector n. Now, take note, OA dot unit vector n is negative, okay, is negative because theta is a cube. No, it's obtuse, sorry. All right, this is theta because theta is obtuse. Now, so what is this distance? Now, the required distance will be d1 plus h, right? Now, d1 plus h, so will be d1 plus the modulus of OA dot unit vector n. Now, if we remove the mod, okay, now then it would be d1 minus OA dot unit vector n. Now, why? Because OA uh, now because OA dot unit vector n is negative, all right, so we need to put a negative here. Negative negative become positive. Okay, now if you look at this, sorry, maybe I should do one more step. All right, then what do you get? You will get d1 minus d. Okay, because d is OA dot unit vector n. Now, so you notice that the distance, all right, the distance, the required distance is the difference of the 2d. All right, you would take the modulus of d1 minus d. All right, now because distance is positive, all right, so you and you notice there is a big D minus a d1 here, and this is a d1 minus the big D, and this is d1 minus the big D. So you just take the difference, all right, and you take the modulus. Now, so what is d1? No, what d1 is a distance of the origin to the plane minus what is big D? Big D is OA dot unit vector n. Okay, so this is the formula.